Hey, my name is Michael Chun, and I'm going to be explaining how to do the linear regression lab from the machine learning course taught by Andrew Ng. So we're asked to implement linear regression with one variable to predict profits for a restaurant franchise. Let's run our packages first. NumPy is for working with matrices and arrays. Matplotlib is for plotting our graphs. Utils is for grading this. Copy is for copying, doing deep copies of arrays. Math is for working with math. Problem statement. We're trying to predict our output, which is our restaurant profits, and our input is going to be the population of cities. X-train is going to be the population for cities, and Y-train is going to be holding our profits. Load data is a function that just puts the data inside of these two variables that we're going to use in this assignment. So before we start our task, there are a few ways that we can get familiar with our data set. The first is to print out what the first five elements of our data. So we can do that. Another way is to look at how big our data looks like. Another way is to actually visualize it with a graph, because I guess we humans are visual creatures, so it makes a lot of sense for us to see what the data looks like on a graph. X-train is, okay, so the population for our first city is going to be multiplied by 10,000. So it's going to be 61,101 people for our city, for our first city, and that's going to be the population. Y-train, the first element over here is the profits in month for a month in terms of 10,000. So it's going to be $17,592. X-train.shape and Y-train.shape give us the number of training examples. So it's going to be 97. Visualize it. So we're using, notice that we're using a scatter plot. Our marker is going to be X, color is going to be red. The title is over here. Y-axis label is over here, and X label is over here, and plt.show just shows us it over here. Our goal is to build a linear regression model to fit this data. Now notice that we can already kind of intuitively tell that our linear regression model is going to look something like this. Follow my cursor. And we're going to use something called the gradient descent algorithm to find optimal values of W and B. And again, our linear regression model is Wx plus B, so we're going to try to find these values of W and B that are optimal. So a refresher on linear regression, like I mentioned. So the model function is going to be Wx plus B, and we're going to have to constantly try to find optimal values of W and B with a method called gradient descent, such that we get lower and lower cost functions. So that our end goal is to get input features. So we're going to be able to input our city population and output a prediction for that profit. So the cost function looks like this, and our first exercise is to try to find to compute a cost function. So prediction looks like that, and the cost function, our cost is going to be FWB minus our actual output, and our cost function is telling us basically how well is our model doing. So the first step is to iterate over all of our training examples. So that's going to be for I in range of M. We're going to get a prediction, which is Wx plus B. And we're going to get a cost for this example. And we're going to square it. And we're going to sum all of our costs together. And then we're going to, well, divide by 2m. Now let's see if that works. Okay, so our cost for initial values of W and B, 2 and 1, is going to be 75. Now gradient descent is going to use simultaneous update on parameters W and B to find optimal values of W and B, such that we're lowering our cost function every single time. The next exercise is to compute our gradient function. So we're trying to find dj dB, which is this thing over here, and dj dW. Notice how dj dB, we're summing all of our gradients for all of our training examples and dividing by m. And we notice this, we already know how to predict our find our prediction from above. So let's start. Iterate through all of our training examples for I in range of m. Our prediction is going to be Wxi plus B. djdB is going to be this term over here. Prediction minus y bracket I. djdW is prediction minus y bracket I times x bracket I. And we're going to divide by m. Let's see if that works. Cool. So it's telling us that, so they're running it for 2 examples. And this is the gradient, what the gradient descent algorithm looks like. Notice how we're taking the cost function and gradient function from above, but we're adding in these 2 terms. The alpha is a constant that basically we can think of it as higher levels of alpha will get to our gradient faster, but ignore what I just said. Number of iterations is the number of times we run our gradient descent algorithm. So this is storing our cost functions. We're going to run it for some number of times. Notice how we get, for our first iteration, we're going to get some djdb, djdw, and djdb using our gradient function we calculated above. We're going to use simultaneous update over here, and we're going to plot it out, see how we're doing. Okay, now we're going to run it using some number of values. Iterations 1500, alpha was 0.01, w and b at 0 each. Okay, cool. So we can notice that our cost function is decreasing as we have higher and higher amounts of iteration, and we're going to find these w and b values. And we can see that our linear regression model looks pretty good because it fits our training set data pretty well. And this is just showing us the prediction for 35,000 people in a city and 70,000 people in a city. Cool. Thanks for watching, and I hope you learned something.